Okay guys, so this here is a Rubins flame tube. So let me kind of explain a little bit about it and how it works. So I have propane in a constant stream through this tube going into this pipe. Okay? Now propane is a flammable gas that's more dense than the air around us. And so in order for it to actually come out of the pipe, we need a constant stream. And the pressure of the gas in the pipe is what helps push it out. Okay? Now, propane, if we were to breathe in large amounts of propane, it's not good for us. But as we burn it, it becomes carbon dioxide, and carbon dioxide is non-toxic. It's safe to breathe carbon dioxide. Okay? Now, on each end of these pipes, there's a little piece of glove. I actually took just a rubber glove, stretched it around, and taped it on. And that behaves kind of like an eardrum. You can see if I barely tap it, you can see how the flames move, right? And if I were to like flick it, it would actually blow all the flames out. Okay, but then I gotta relight them, and I gotta wait for the pipe to refill, so I'm not doing it. Okay? Alright, so our plan today, we're gonna do some experiments with amplitude and frequency, and then we're gonna play some music and make some observations. Then at the end of class, just for fun, we'll pull down the screen, turn on the projector, and like play music videos while running music through it, and kind of just enjoy that experience. The slide. So first we want to examine amplitude. Okay. Now we mentioned amplitude is the height of a wave, but we can't see a sound wave. So how do you think amplitude might sound? If we change the amplitude of a sound wave, how would it make it sound differently? Let's give you a second to fill in your theory as to how you think the amplitude would sound differently if we change the amplitude of a sound wave. Okay? What do you think? Anyone want to share their theory? I'm going with Ashley.
I thought it would sound louder if the amplitude increased.
You think if we increase the amplitude, it'll sound louder. So you think amplitude and volume are connected. Okay? That's a good theory. Anyone have a different idea? Aubrey. You think it'll change the pitch. So higher amplitude, higher pitch. Pitch is like the notes, okay? Let's give this a shot. Now, one thing you're going to see me do a lot is I'm going to be adjusting how much the propane's going into the tank, because if the flames are too high, like if they're really big, then you actually don't see much of a difference from the waves. So I actually want to keep them fairly small, but if they're too small, they blow out, and I spend a bunch of time relighting. So you'll see me kind of moving. If you see me moving around, that's what I'm doing. Okay, so let's start by playing a sound wave here. Okay, so we've got a sound wave going through the pipe, and we can see it's making multiple waves. Okay, I'm now going to increase the amplitude of the sound wave. You should see the wave increase in height, because that's the amplitude is the height. But I want you to listen and see how does it sound differently as well. Okay. So, relight some of these.
That's cool how you can relight it.
All right. So, how did changing the amplitude change the sound wave? What happened? I need to do it again.
The waves increased.
What's that?
The waves increased.
The waves got bigger, but how did it sound different?
It sounded louder.
Yeah, it got louder, right? So the waves got taller, and we heard Ashley's theory was right, that the volume increased. Okay? So volume and amplitude are the same thing. If I want a higher amplitude, I talk in a higher voice. If I want a lower amplitude, I talk in a lower. Right? Does that make sense? All right. Now, you're also asked, why is the amplitude larger at the speaker than it is at the other side of the tube? Did you guys notice that? That the amplitude was higher down here near the speaker than down here away from the speaker. Okay? Let's look at it again and see what we're talking about here. Okay, so if we look, you can see the amplitude's higher here, and it goes down over time. And it's easiest to see if we look at these low spots, the nodes. This is our node here, which is the same as this here, where there's just tiny flames, and it's just the same as here, where there's no flame at all. Okay, so we definitely see a decrease in amplitude. It's getting lower and lower the farther away from the speaker it goes. So why is that? Why are we seeing a decrease in amplitude? Yeah,
Because it loses energy over time.
because it loses energy over space, right? The farther it gets from its source, the less energy it has, right? We learned the other day with that bungee cord and the drill that if we increase the energy, it'll increase the size of the amplitude, okay? And so it's losing energy the farther it gets away, which that also makes sense to us, because if you can't hear somebody, what do you intuitively do? I mean, nowadays you go like this, but normally you lean in, right? You're trying to get closer to them so you can hear them. Okay? If somebody's on the far end of the room, they don't hear me as well as somebody who's right close. Okay, does that make sense? All right. And then the other question, what is a better definition of amplitude than height of the wave? You can't see a wavelength, or you can't see a sound wave. So like height doesn't work there. What's a term we could use that would apply to both height as well as volume?
It's louder, it's bigger.
Intensity. I actually said that the other day to kind of plant that seed that we will, from now on, we'll be considering the definition of amplitude to be the intensity of a wave, because that applies to both height as well as volume. And one other type of wave that we'll look at next week. Excuse me. Okay? All right. Now let's look at frequency. Okay, let's do an experiment here with frequency. If we change the frequency of the wave, how will we notice that frequency changed by listening to it? How do you think that will sound differently? Go ahead and record your theory, okay, for how you think changing the frequency will make a sound wave sound differently. Okay, what's your theory? Anyone want to share? Aiden?
The pitch.
You think it'll be the pitch, right? The note that is applied. So you're saying higher pitch will have a higher frequency. So if I talk up high, it's a higher frequency. If I talk down low, it's a lower frequency, right? It's kind of what we're going on. Well, let's find out. Now, sound waves move so quickly, right, that you're not going to see a wave travel down the pipe, but you will see that standing wave. So higher frequency, we're going to see more waves occurring, right? So let's give that a whirl. So here we have 1, 2, 3 waves. Okay, higher frequency, we've got 1, 2, 3, 4 waves. Oh. So here we've got 1, 2, 3, 4, 5, 6 waves. So as we changed frequency, how did it sound different? You guys listened, right? How did it sound different? Yeah.
It changed. I think Aiden was right about it changed pitch.
Yeah, it changes pitch, right? It goes up in note. Okay? So we have a change in pitch. Alright. Now, did you guys notice whether or not it lost energy the farther it got from the speaker? The amplitude lost energy, right? We already talked about that. Does the frequency also lose energy the farther it gets from the speaker? If it were, what would that look like? Just so we know we'd be able to identify it. The waves that get farther apart. So if we were to draw that, it might look like this, where the waves are close together and they get farther and farther apart. Where if we were to look at wavelength, we see a closer wavelength and then it's farther, farther, and farther apart. Right? That would make sense. So let's look at the wave again, and this time I'll use a ruler and measure what the wavelength is, and we'll see if the wavelength changes the farther we get from the pipe, or from the speaker.
Hopefully you don't
Okay.
set the ruler on fire.
Yeah. So that's about 1 foot, 1 foot, 1 foot, still the same, and still the same. So was there ever a change? No, we never saw a change in the wavelength, so therefore the frequency does not lose energy the farther it gets from the source. Which also, just like amplitude makes sense. Just like with amplitude, the farther you get from somebody, the quieter they are. The farther you get from someone, does their voice change? No. Otherwise, it would suck to go to a music concert. Because like the people in the front row, it would sound amazing, and the people in the nosebleeds, it would sound like garbage. What's actually happening in the pipe, okay? So I've drawn a version of the pipe, you guys have it as well. What type of wave do you think is a sound wave? Is it transverse or longitudinal? What, maybe we need to review. What's the difference between a transverse and a longitudinal wave? Yeah.
Longitudinal goes with the particles, and transverse goes against.
Okay, so transverse, the particles are moving up and down. That's the wave that looks like that, right? Where a longitudinal wave, the particles are moving like this, and so they're creating compressions and decompressions, also called a compression wave, right? So any ideas which of those a sound wave would be? You think it's the first one, it's going up and down? Okay. Anyone gonna take a vote that it's the second one?
Wait, what's rally?
A type of earthquake wave.
What?
A type of earthquake wave. So let's think about this for a minute. So when we play a frequency through the pipe, we have regions where the flames are taller and regions where they're smaller. I mentioned at the beginning that because propane is heavy, it's very dense, it has to be pushed out the pipe. So regions that are taller, what would make them push farther out the pipe? Maybe more pressure, right? Well, if we were to draw that and consider the particles that are in the pipe, we would draw this and show that there's more pressure or a higher density of those particles where the flames are the highest, and then they get loose where the flames are more spread apart. And then it gets more condensed where it's together and the flames are higher, and then loose again. Okay? So a sound wave is actually a longitudinal wave. We can tell because it's creating these compressions that force more propane out, creating a higher wave. Does that make sense? Okay? So our particles are moving back and forth, and so we're creating areas of high pressure and areas of low pressure for a high flame and a low flame. Okay? All right. There's also a couple of videos there on the, not videos, a couple of questions on the last slide for you to answer as well. For now, what we're going to do is we're going to listen to some music, and we'll make some observations. Then, in a minute, we'll play some music videos. Kind of just enjoy doing that. Okay?